Hello and welcome to this new Construct 3 tutorial where I will show you a new take on creating Tetris in Construct 3. Now I know there is the falling shapes tutorial, built-in tutorial within the Construct suite here, but this game works slightly different and I would like to show you how to also do it differently. So right here you can see the end result and how it works. Let's just go look at the code and what we are doing. So this is the main layout of the game. It consists out of a number of layers, of course. The background is just where the game background resides and also where the game backlay objects reside. They are used to check for the edges here, and that's the blue things. Now the bricks themselves, they go on the bricks layer, and there's also a separate layer for the HUD and the game over dialog, which you can see here and here. The principle of the game is very well known, I suppose. There are 6 different blocks in Tetris, and you can see them all at the top of the layout here. They are. However, the images you see are not the blocks that you see in the game. That's because the blocks need to be able to be divided into separate parts when the lines are removed from the board. So instead, they all consist out of brick part objects, which you can see in the bricks layout. So as I said, it has its own layout because you know in Construct you need at least one instance of everything. And here you can see it. The brick part object contains a few behaviors. First and foremost, there's the tile movement behavior. You can see it here. It allows the tiles. It follows the tiles in the game, so the same as the grid of the layout, 64 by 64 pixels. Now, to align perfectly with the grid of the layout, the origin point is not in the middle, but at the top left. So as you can see in the code, at some places this is done. There's something done to compensate for that. So here it is, the origin point in the top left. Next to that, there is the move to behavior for it to be able to move outside of the layout when a line is removed. So also the move to behavior, you can see that here. So there are also a number of instance variables as well. The block keeper instance variable is a numeric identifier that ties all of the blocks in a template together. The ID instance variable is the ID of the block within the template, and the rotation state is used to determine how the template is currently rotated. The template is a reminder of what template the block belongs to, and the mark for removal instance variable is used to remove the lines actually. So if we go back to the main layout, back to the essence of the way of working, actually when a brick is spawned, it's done using one of 6 different templates. These are the 6 different templates, you can see them here. These 6 different templates, and they always consist out of 4 parts that move together. When the user moves the brick with arrow keys, all bricks go along. Rotating is a different matter, and actually a bit tricky, because when rotating the block, the individual parts need to move along the grid. To understand best, just look at the arrangement of the bricks at top layout. Each template has a number ranging from 0 to 5. And you can see all of the bricks here ranging from 0 to 5. And there's also a rotation state going from 0 to 3. So you can see here that this template, the long flat block, in rotation state looks like this. The numbers in the different parts are the IDs. So this has ID 0, ID 1, ID 2, and ID 3. The little pink block here is the rotation point. So if it goes and rotates, you can see it rotates from rotation state 0 to rotation state 1. But this point stays the same. You can look at it like that as well. Once you go to rotation state 3, you go once you are on rotation state 3, you rotate, you go back to 0. It's just a cycling movement. Now, in order to make that move, we have 2 3-dimensional arrays to make the movement, to make the rotation go as planned. So let me show you how that works. There are two JSON files attached to the project, and you can see there is a rotation matrix for X and there is a rotation matrix for Y. How does it work? Let's start with X. Here you can see the IDs and the rotation states at X and Y axis, and the depth, it's a three-dimensional array, is the template. So what we're seeing here, we're now at sheet 0, meaning template 1, which is this one. And if you look at template 0, and we want to go from rotation state 0 to rotation state 1, and you start from the premise that the block with a little pink block in there, the ID with a little pink block, which is ID 1, stays at the same place, you have to say that ID 0 goes up a part and right a part, because let's superimpose them. So going from this state to this state, the 0 ID goes up and right one part, and the 2 ID goes down and left one part, and the 3 ID goes down 2 and left 2. That's how you need to see it, and this is how that reflects in here in that rotation matrix. So for template 0, the X coordinate goes right 1 when we're at rotation state 0, 1, the 0 ID go when we're at rotation state 0, the 0 ID goes right one part, ID 2 goes left 2 parts, one part, and ID 3 goes right left 2 parts. So minus means left, plus means right, 0 means stay in its place. And you see that the 1 ID stays the same every time. So it's not moving because it's 0. And that's also what we see here. This one is the rotation point. So the rotation point is not moving. So that's how it works. Rotation matrix 1, where we can see all the matrix, a matrix where you can see all the tile movements of the different IDs within the different rotation states for every single template. The same thing applies for the rotation matrix Y, of course, where it's Y coordinates. -1 means 1 tile up, +1 means 1 tile down, -2, 2 tiles up, and stuff like that. So we will see in a minute how that's used inside the game. So we're almost finished here with the layout. The last thing we want to mention that there's a timer object here, and so its only purpose is just to have a timer which takes care of the block gradually falling down without the user pressing something. So that's basically the layout and the main essence of the game. Let me see how that is implemented here. So the game consists out of a number of groupings here. There's something for the dialogue, there's something for a consolidation, which I'll come back to that in a moment, for spawning, movement, and initialization. So let's start with the initialization. So on start of layout, we were just hiding the game over dialogue, which is logical. And we initialize some variables that are used in the game later on. So we need a current block to identify which block is currently moving, and we also need a moving blocks semaphore to use when a line goes out of the layout, to know when all of the blocks all of the block parts rather have stopped moving, and we can go on with the game. Consolidating is a flag that is set when the items are consolidated, which means that once a line has been removed, all the parts that are now more up above in the layout need to drop down to the next possible place where they can move down to. We'll see that in a minute. And then we will spawn a random brick, and we can load the rotation matrices. We do that using the Ajax plugin. We just wait using the asynchronous functionality of Construct 3 and we load them into the respective arrays here. So we start the timer for every half a second, and we set move allowed to 1. And then we check if the best item exists in the local storage, which will result in either the on item missing or on item exist events being fired. So on best item missing, we just initialize the score, and if it exists, we get it, and we set the best score to the correct value. So basically that's it. Now for the movement, the first thing we will do is on every tick, we will set the score and the best score. But then there are some helper functions, and the helper functions, the first 4 you can see here are checking if a block can do something. So a block consisting of multiple block parts can move into a certain direction, and the direction is given as a parameter. So directions can include L for left, R for right, and D for down. So we start from the assumption that it is allowed. So we have a result value which is set to 1 by default, and we pick the brick part of the block that is currently falling. The block that's currently falling, the ID of it is stored in the current block global variable, and also that ID is kept in the block keeper in the block keeper instance variable rather of the brick part. So we pick every brick part which is currently falling. That's actually what we're doing here. For each of that brick part, we will set the result value to the minimum of what we already have as a result value, and a value that's determined by another helper function called can part move to direction. So by ensuring, by doing a minimum here, we ensure that once it goes to 0, it always stays on 0. And that's what we return in can block move to direction. The can part move to direction is the helper function we just used in the can block move to direction. So here we are picking the part that's giving as a parameter and determining the x and y coordinate to check. So that's the x plus or minus an offset. If we're moving left, half a part size, because the origin is at the top left, so it's moving. If it's moving to the right, we need 1.5 part size to check. So let me show you here how that works by going to the brick layout here. Suppose we're checking. If we're going to the left, we don't need to subtract a whole brick part because it's not starting from the middle, it's starting from the top left. So instead of subtracting a whole brick part to check if there is a brick here, we start from here and we subtract half of a brick to check if there is a brick there. If there is no brick there, okay, it can move left. Same thing here, if we go to the right, we need to check if there is a brick here, but if we add one single brick part, we will always end up here at this side. And that's not the correct place to be checking if there is a brick or not, it's here. So we need to check 1.5 brick part to the right. And that's what we're doing here. So we set some helper variables, x and y, to the brick part plus minus 32 if it's left, or plus 69 if it's a right. Either, and otherwise it is 32. So the same thing for y, there is 69 or 32. And we check if there is a brick at that x and y coordinate, if it's overlapping a brick, which is not in the current block, of course. If it is, then we set the result value to 0, and also if we're overlapping a backlay which is going out of the layout, we set the result value to 0. So that's how the can part move to direction works. The same type of thing we have for the can block rotate. Rotate, excuse me, returns 1 or a 0, of course, and we start from the assumption that it can, and then we go to the for each block in the current, for each brick part in the current block, excuse me, and then we set again the result value to the minimum of what it's currently now, and functions can part rotate, and the part rotate is here below. And again, we just pick the brick part which you're checking, and we set the x and y offset to another function, then doing get new x offset and get new y offset. Using the x offset and y offset, we calculate the x and y temporary variables, and then we check if it's overlapping that x and y, just like we did with the can part move to direction actually. But this x and y offsets are actually these offsets here in those matrices. So here the x offset, because we're checking rotation matrix x, the x offset can be 1 or 0 or -1 or -2, yeah, and that's what we're getting here. Actually, that's what we're getting: 1, 0, -1, etc. We calculate the x and y from that, and we get it here from we get result by checking if it's overlapping a brick or overlapping an overlay. Now, getting that get new y offset and get new x offset is very simple. It's just one action here, which gets the return value from the rotation matrix x at ID, rotation state, and template. So that's ID, rotation state, and template, and of course that's x, y, and z, which is x, y, and the depth is z. That's the way you see it. Same thing for get new x offset for the x values in the rotation matrix x array. And then there's a very simple thing for rotating a block, where we break every brick part in the current block again, and for each of them we set the tile movement grid position to a cell which is the current movement x plus the x and y offset, and the y plus the y offset, and then we just change the rotation state. So what we're actually saying is, get me the offset for the x and the y, get me the offset from the x and the y, and just add it to the current grid x and the current grid y. For example, we are now evaluating a certain brick part, and in order to move from rotation state 0 to 1, for example, it needs to go right one part. So what we'll get here, for instance, we are now at grid x 3, for example, and it needs to go right 1, then the get new x offset function will return the 1. So 3 plus 1 will be 4. Same thing for y, and we move there instantly. And by moving there instantly, and not through an animation here, by instantly, we actually get the idea that the block is fluidly rotating. And in order to get the correct rotation state next time we rotate, we have to say that, okay, we have to do, if the rotation state is 3, we go to rotation state by 1 again, and else we set the rotation state to the rotation state plus 1. That's actually what we're saying here. Very simple. So in practice, let me see here how it works. So now we spawn the brick, we press the up key and it rotates. So for every time we rotate, we get, for every brick part in that brick, we get the x offset and the y offset. And here, for example, everything will be 0 because it doesn't need to be rotating here. So every time that happens, it rotates. So now we go to the interaction. Interaction, when we press the left button part, we pick the button, we pick all of the parts in the current block, which is currently dropping, and the move is allowed. Then we check using the can block move to a direction left. If it can, then we move one Y position to the left. That's here what we're doing. And here we do the same thing for right. If we can block move to direction right, then we go to the right. The same for going down here, exactly the same. And when we're pressing up, we need to check can block rotate yes or no. And if it can, we just rotate the block. Now you can see here that on the down press, we also check if a block cannot go down anymore, and if it can't go down anymore, so this function will return a 0. That means that we've landed somewhere on a block, and we should check for the grid if it got lines to be removed, and that's done in this function check grid, which I'll come back to in a minute. So for spawning, there's a function spawn brick. There's a function spawn template and a function spawn part. So we start with a spawn brick, and what we do here as a first thing is we check if there is a game over situation. And the game over situation is just we check if there is a brick part at the tile movement behavior grid y equals 5. So if there is somewhere a brick on the y coordinate 5, that means that the blocks have stacked up so high that the game is over. And if we check that, that will be, let me just activate the grid here. So this is 1, 2, 3, 4, 5. If there is a brick part here, means we're reaching the top of the layout, and of course that needs to be a game over situation. So here, that's what we do. If there is not a game over situation found, so that's found will not be set to 1. If nothing is found, we increase the current block counter and we spawn a random template with it. So add enter the current block, and then we spawn a template with the current block. The template to spawn is just a floor of random 6, excuse me, which will result in a number from 0 to 5, of course. And we start the timer again. We set move to allowed, and if it's set found is equal to 1, which means that we found that brick part at grid y 5, we just show the dialog, and we don't set move allowed to 1. For spawn template, we get a template passed as a parameter and the block keeper number, and then we set it to a random color. And what we do here is based on the template we get as a parameter. If it's template 0, then we spawn those 4 parts. For template 1, we spawn those 4 parts. And when we do a spawn part, that's actually what we're doing here. We're spawning it at an X and Y cell position, which can be 3, 5, 4, 5, 4, 4, etc. The number of the block keeper, the ID we're spawning, because we're always spawning 4 IDs, 0, 1, 2, 3. The template, of course, and the color. And we pick the last created brick part, and we just set tile movement to the correct cell, the block keeper ID template, and we use the replace color effect, which is here on the brick part. We have a replace color effect, which will replace the black color with a certain tolerance. And what we see here is we set parameter 1, which is the color, of course, to that color. So here we have the consolidation, and remember when we said if we are landing somewhere, we need to check the grid if there are rows that need to be removed. So we use a timer object, and when we check the grid, we pause the timer, because then the blocks don't need to be falling anymore. And we init some variables that start from the row from which the checking needs to happen. So the start row starts at -1, and the number of rows that will be removed, we initialize it to 0. So we avoid that the user can control the block while the consolidation is happening here. So we start by looping through the rows from 16, which is the bottom, to 3, which is the top. Loop through all of the rows in the grid. Here we do that using the loop index, and if a row contains 10 bricks, then the row is full. Then we will mark all of those bricks for removal, add 1 to the number of rows, and increase the total on the bust score if needed. So if there was no start row set yet, we set the start row so the consolidation can use it to know which blocks have to fall down. So we start the start row here. And then for everything that's been marked for removal, so here we pick all the parts and we set a semaphore called consolidating to 0. Doing that means that the consolidation process has not started yet. So first the rows need to be removed. The reason why the flag is set, because both removing a row and consolidating the following blocks will trigger a can move arrived trigger. Only when we're not consolidating, the parts should be destroyed, of course. So we set consolidating to 0. We move the parts out of the screen with the move to behavior, and we increase the counter to keep track of the blocks, of the moving blocks, which are checked on move to arrived, which we'll check here. And if there's nothing found anymore, we can spawn a new brick. So when a brick moves to a certain point and it arrives, this trigger is being fired. We subtract 1 from the moving blocks, which will happen for every block arriving. And when consolidating is 0, we will be destroying the brick part once it is arrived. If we're consolidating, we're moving a block down inside the grid, and we don't need to be destroying it, of course. So when all blocks have done moving, we can call consolidate, which will in turn again call the move to arrived here, but with the consolidation set to 1, so it won't go and destroy the brick. And then we can spawn a new brick at the end of that process. And then finally we have the consolidation function, which we use here, and we're starting with setting the consolidation process to 1 here, set consolidating 1, so the parts don't get destroyed there. And we start from the starting row, which has been set here, and then we loop through that by picking all of those bricks, and for each brick we move all of them down by a number of rows. So if there are 2 rows removed, they all should move down 2 places, for example. That's what we're doing here with num rows, and these num rows are also determined here. So basically, let me show that here. Suppose blocks are falling down, and the last 2 rows, for example, will be removed. Then the start rows variable will be 0, and the num rows will be 2. So these 2 will be removed, and everything above that will drop down 2 blocks. That's basically how it works. And finally, the dialog just shows you the dialog and hides the dialog by showing and hiding the layer, and will activate and deactivate logic in that group. That's it. That's how this alternative to falling shapes works. I hope you liked it. So as always, please like and subscribe, and I will leave a link in the description where you can download the template at the Sira store. Thank you for watching.